Good morning, dear students, and welcome back. Today, I am going to record lecture number 9. This is the lecture number 9, children. Okay, so here we are going to discuss about the lecture number 9 today. Hope you people are doing good. And till the last video, we have finished here. Now, we'll solve some problem related to this statement, and further we'll discuss new topic also. So you are watching this video on my YouTube channel at the rate Govind Chemistry, and hope your preparation is going well. I am just helping you. Don't depend upon me, but whatever topic I am completing, that is 100% covered as for all competitive exam point of view, for your board point of view. So, but not depends 100% on me, because all the syllabus I cannot complete here. Okay, so it's for you. There is no cost, it's a free cost content. So I hope you are enjoying the content. So the question is, find the value of delta H minus delta E for the reaction at 25 degrees Celsius in kilojoule, and reaction is 2C6H6 plus 15O2. It gives 12 CO2 plus 6 H2O. This is in liquid state, gaseous state, and it is also in liquid state. Okay. Options are given. Option A minus 7.4, option B minus 3.2, option C plus 7.4, and option D plus 3.2. These are the options, and that is the question given. They are asking the value of delta H minus delta E. So what relation we know, that delta H is equal to delta E plus delta NGRT. So from here, delta H minus delta E is equal to delta NGRT. So how to find Ng? Delta Ng is equal to gaseous substance of product minus reactant. So here 12 product, and here 15. So delta Ng will be 3. So delta H minus delta E is equal to minus 3. R value 8.314 multiplied by temperature 25 degrees Celsius, then convert it into the Kelvin. So 298. So from here it will be 7.2 minus 7.2, sorry, multiply this value. Wait 1 minute, I will multiply. So it is 3 multiplied by 8.314 multiplied by 298. So it is something 74, minus sign is there. It will be minus 7432. Okay, that value is coming in joule, and we have to convert it into kilojoule. Then that is in joule, then divided by 1000. So what it will be? 7.4. So which answer will be correct? Minus 7.4. That is the correct answer. This is the question number 1. Is there any problem? No. Now question number 2. Find the difference between heat content. Find the difference between heat content heat content at constant pressure and constant volume for given reaction at temperature T. So what they are asking? Heat content. They are asking heat content at constant pressure and constant volume given reaction and temperature is T. Reaction is given 3C3H8 gas plus 5O2 gives 3CO2 plus 4H2O. It is gas and it is liquid. Options are given: A is equal to minus 3RT, B is equal to minus 2RT, C is equal to plus 2RT, and D is equal to plus 3RT. So from here, what is delta Ng, children? So gaseous 3 minus 5 plus 1 6 is equal to minus 3. Then heat content is what? Qp minus Qv. Okay, difference they are asking, value of Qp minus Qv. So you know that Qp is represented at delta H and it will be delta U is equal to delta NgRT. So it will be minus 3RT. Qp is what? Qp is what? Delta H. Qv is what? Delta U. This is this, this is this. So what is the answer? First answer will be right. So these are the two questions from the previous topic, lecture number 8. Now for today we are going to start one new topic, heat of reaction. What is the topic today? Heat of reaction. In this case, heat of reaction, children, heat of reaction is what? That means delta H, enthalpy change. What you have to find out? Enthalpy change. And how to find? Suppose any reaction is happening, reactant to product. So what is delta H in that case? Delta H is equal to heat of product minus heat of reactant. That is the heat of reaction. Delta H, if delta H is negative, what? Delta H negative, then what is the meaning? Energy released. Okay, energy released means the process is, reaction is exothermic. That means heat of reactant is greater than heat of product. How, sir? I will tell you. Don't worry, children. If delta H value is positive, then energy absorbed. What means energy absorbed? These are the small things. I know you people getting bored, but you have to focus. Endothermic means you have to provide energy for the reaction completion. So here product energy is more than reactant energy. So little back means go to the equilibrium topic. In the equilibrium, children, if I am making a graph of energy, okay, phase of reaction, and here it's a energy and it's a phase. So here and one more at the same time, same thing. Okay, here what is the thing, children? If you remember, in the case of this is reactant and this is product, so it's happening like this. Here it's happening like this: reactant energy is more than product, and here this is reactant and this is product, so it's happening like this. Here activation energy somewhere you will get, so it is not our topic. So this is exothermic and this is endothermic. Simply you understand, if delta H is negative then exothermic, if delta H is positive then endothermic. Okay, so let's take one example, then this will be more clear. So example is given. What example, children? Example is given: NaOH plus HCl. So what they will form? NaCl plus H2O. That is the reaction. NaCl aqueous, this is liquid, they also in aqueous state, and here plus 13 kilocalorie. So that means delta H value is minus 13. Minus 13 means it is releasing 13 kilocalorie energy. So this reaction is exothermic, children. What exothermic? You can write 13 kilocalorie per mole of per mole of NaOH, because everyone is one mole, or per mole of HCl, or per mole of NaCl, or you can say per mole of H2O also. Okay, that is the meaning. Same time, this is the example number 1. Example number 2, here I am telling you carbon solid state plus 2H2O gas it is CO plus H2O, not H2O, it's a H2. It's a H2, and this is also in gaseous state, and minus 30 kilocalorie. So minus 30 kilocalorie, that means here left side it will be positive. So delta H is equal to plus 30 kilocalorie. So this reaction is what, children? This reaction is endothermic reaction. Endothermic reaction means what? For that you have to provide 30 kilocalorie energy, then it will be possible. Okay, so you can write 30 kilocalorie per mole of C per mole of carbon per mole of H2O. No, not H2O, 2 moles are there. Per mole of CO, per mole of CO, like that you can represent. Once again I am telling you, 30 kilocalorie per mole of carbon, per mole of CO, per mole of H2, and 30 kilocalorie per mole of, not per 2 mole of H2, 2 mole of H2O, like that you can represent. So these are the type of reaction, exothermic and endothermic. Okay, now we will discuss about factor on which delta H depends. Delta H factor on which it depends. Factor on which it's depend. So first factor is, children, physical state of reactant and product. Okay, delta H value depends upon the physical state. So how it will be? Like H2 gas plus half O2 gas, and they are forming H2O gas. In that case, delta H is equal to minus 60. At the same time, H2 gas, half O2 gas, and they are forming H2O liquid. Here delta H is minus 70. So you can check the difference. Here water in gaseous state, here water in liquid state. Here less energy you are getting, here more energy are you getting. Why? From here to here, gas to liquid, what you have to do? You have to condense the gas. That time also energy released, 10 joule energy will be released. Okay, so it depends upon the physical state of reactants and product. Number 2, allotropic form of reactant and products. It depends upon allotropic form of reactant and product. Like C means diamond, carbon in which form? Diamond. O2, it is forming CO2 gas, so here it is delta H1, and C, amorphous or graphite, anything. O2, it is forming CO2 gas, here delta H2. So delta H1 cannot be equal to delta H2. So it depends upon the allotropic form. Got it? Number 3, solution in which reaction take place. Solution in which reaction take place, it's depend upon that also. Solution means solvent. In which solvent reaction is carried out, it depends upon that also. And very important point number 4, it depends upon temperature and pressure. Okay, so one thing, one standardized value is there. Standardized value means what? At the, if temperature is 298 Kelvin, you can say room temperature. Pressure is 1 atm, and aqueous solution concentration of aqueous solution is 1 molar. Concentration of aqueous solution is 1 molar. 1 mole. That means 1 mole per liter. 1 mole per liter. That time enthalpy is represented at H naught, standard change in enthalpy. Standard change in enthalpy. So these are the factors on which enthalpy change depends. Hope you are getting it. Next is standard enthalpy. Standard enthalpy will be 0. What will be? It will be 0. At what? 1 atm pressure and 25 degrees Celsius temperature, standard enthalpy will be 0. For what? Free naturally occurring state. In free naturally occurring state, if anything is in free naturally occurring state with 1 atm pressure and 25 degrees Celsius temperature, then standard enthalpy will be 0. Like what, children? Example, like delta H naught for Cl2 with 0 naturally occurring state, delta H naught O2 naturally occurring state, delta H naught N2 0. Similarly, delta H naught C means carbon, and carbon naturally occurring site is graphite. Okay, graphite is naturally occurring, so here it will be 0. If delta H naught C for diamond, so in the case of diamond is made by graphite after long process, so this is not equal to 0. Similarly, in other allotropic form like delta H naught for sulfur-8, that is 0, remaining are not. Sulfur-8 is what? Orthorhombic. It is orthorhombic. Similarly, delta H naught for P4, that is 0. That is white. That is the naturally occurring phosphorus. Okay, that you have to remember. So this is the standard enthalpy about it. Standard enthalpy at 25 degrees Celsius and 1 atm pressure for naturally occurring state, it will be 0. Got it? In the next case, we are going to discuss about the enthalpy of formation. Okay, so I hope it's enough, because almost 23 minutes completed, but I think we will complete enthalpy of formation. It will take time is around 10:21. So enthalpy of formation we will complete in the next video. So this is all for this lecture number 9. Thank you for watching. Be happy and study well.